The following interim VIVA presentation is in regards to the project titled Are Virtual Reality and Artificial Intelligence Effective in Improving Construction Risk Communication in the UK? As presented in Figure 1, in 2023, the construction industry was reported to contribute a fatal injury rate of 1.63 per 100,000 workers. Incidents in construction can result due to a range of reasons: equipment failure, lack of training, and most notably, poor risk communication. The objective of this research project is to therefore explore the potential of AI and VR in improving risk communication in the construction health and safety. Both VR and AI present potential to revolutionize risk communication in construction. VR offers immersive virtual environments where hazards can be experienced by any individual without real world consequences. AI, on the other hand, referring to advanced computer algorithms that can emulate tasks requiring human intelligence, can be used to forecast potential risks as well as making suggestions for preventative measures. Prior to commencing the exploration of advantages of AI and VR in communicating health and safety risks, it was important to establish the current state of the art in health and safety communication. Typically in the UK, methods such as toolbox meetings, handbooks, and briefings were used to communicate health and safety risks. Most recently, the rapidly growing implementation of BIM has also become a huge component of visualizing and communicating health and safety risks to site workers. Having engaged in a critical review of literature of disadvantages of current risk communication strategies, five main challenges were identified, those being retention and engagement, consistency of communication, language and cultural barriers, over-reliance on paperwork, and failure in risk recognition. These challenges therefore imply the need for exploration of new methods of health and safety risk communication in construction. The proposed project suggests two main components of work to answer the primary research question: are virtual reality and artificial intelligence effective in improving construction risk communication in the UK? The first proposed method is to conduct a risk visualization experiment with 20 participants from the CEG department. The second proposed method is to conduct two interviews with industry professionals to gauge with their awareness and perspective of the application of VR and AI in health and safety risk communication. Figure 6 portrays the selected project to be used for the risk visualization experiment. Participants of the experiment will be asked to engage in a safety briefing regarding the construction of composite steel balconies in the residential building presented in the previous figure, as well as any other important site safety procedure. The 20 participants will be split up into four groups. Each group will receive a brief of the construction sequence of the proposed works. The four main methods of communication will be construction drawings, a PowerPoint presentation, a group VR simulation led by an instructor, and an individual VR simulation led by a participant. Once the briefing process is complete with the respective methods, the participants will anonymously answer two questions. The first question will gauge their understanding of what risks they associated to each different construction step. The second question will ask the participant to rate each construction step in terms of its perceived severability and perceived vulnerability. Each participant's score will be added up, and an average score will be produced for each individual method of risk communication. As a general rule of thumb, the higher the score, the more effective the method of communication. In regards to the interviews, the primary inclusion requirement for the interviewees are as follows. Any selected participant must have at least some basic awareness as to what AI and VR is without any particular expertise. There are two designated roles being sought out for regarding potential interviewees. The first role is that of a designer with experience in handling the health and safety file of a project. The second role is that of a health and safety manager that has experience in site briefings and coordination of health and safety on site. Once the interviews have been completed, they shall be transcribed verbatim. The interview transcripts will then undergo two processes called open and axial coding. These processes essentially highlight relevant phrases from the interviews, categorizing them. Once a set number of categories have been established, they shall be used in the discussion section of the project to answer the overarching question of what awareness does the UK construction industry have of VR and AI being used in health and safety risk communication? The following recording is a trial version of the 3D model intended to be used in the risk visualization experiment. Having now concluded the brief introduction, we will now move on to the question and answer section of the presentation. Thank you.